Now, let's say I'm an engineer and I want to analyze why our overall equipment effectiveness has not been so high during some time periods. Remember, overall equipment effectiveness, or OEE, is just a way to monitor the availability, performance, and quality of my assets. I used to go into Excel, find my particular assets, and then pull historical data back. For each of my assets, I had to really determine the time periods where we had the downtime. After I find the timestamps of the downtime events, I had to go back and sift through the data before the particular downtime in order to try to figure out why that problem occurred. This really took a long time, and downtime events can be pretty costly. Let's go ahead and see how Pi event frames can help out here. Now we're back inside of PySystem Explorer, and the automatic detection events really consists of two different components. One is the definition of what event is, the event type, and that's configured by what's known as an event frame template. The second component is known as the configuration of the event frame generation. How do you define what the start of an event is and what the end of an event is? Let's go ahead and see how we can do both of those. I'm going to go ahead and go to library. You'll notice that in the library we have a bunch of different types of templates. We have element templates and we have event frame templates. Let's go ahead and create a new event frame template to capture a downtime event. I'll go ahead and create a new template. I'll call this template downtime. Now, event frame templates basically define the types of events that we have. They contain attributes that capture information specific to that event. And I'm going to go to the attribute templates section. In a sense, event frame templates and element templates are very similar. Event frame templates can have attributes that are linked to pipe point data references, to table lookups, to formula data references. Now, for the downtimes, I want to capture the duration. How long does downtime last for? I want to capture the shift. What shift did this downtime occur in? I want to capture the status and default codes for this particular downtime. And I want to capture the average production rate over this entire downtime. So let's go ahead and start with the status. I'll create a new attribute template. I'll give this attribute a name of status. There's no unit measure for status because it's just a string. For the value type, I'm going to select the status enumeration set. And for the data reference, I'm going to select pipe point. Now I'm going to go to settings to configure this reference. Now typically you can define the data reference two ways. You can link it directly to a pi tag, or you can link to a particular attribute. Now the attributes that we want to reference are not from the event frame template. They're actually coming in from the element or the element template that's linked to the asset that generated this event frame. And to reference these elements, you need to use specific syntax. The way you will reference the status attribute in the reference element is with these series of characters. Now let's go ahead and break this down a little bit. I just type in dot backslash elements with a capital E, open square bracket, dot closing square bracket, pipe status. This looks a little bit confusing. The dot backslash elements with a open square bracket, closing square bracket basically returns a list of all the reference elements for this particular event frame. When I have a period between the brackets, that basically tells me that I want to reference an attribute from the primary reference element. The primary reference element is essentially the asset that was linked to this event. For example, if our equipment goes down and we generate a downtime event frame, the equipment that went down is the primary reference element. Generally, if you only have one primary reference element or one asset that's going to generate this particular type of downtime event frame, you would typically just use dot backslash elements open square bracket dot closing square bracket. The pipe status basically says from the primary reference element, give me the attribute with the name of status and return its value. Now, one thing to note here is that we have the by time range specified as the end time. So when we look at this event frame and look at the value of the status attribute, it's going to give me the value at the end of this particular event frame. Well, at the end of the event frame, my status might change automatically because my event frame stopped. And the status might have gone from a downtime state into a non-downtime state. So for my by time range dropdown, I'm going to select start time. And this will give me the value at the start of the event frame, which will most likely be a downtime event status. Now let's go ahead and create another attribute template called fault code. I know in my OEE equipments, I have a attribute called fault code that captures the reason for any types of faults that have occurred for that piece of equipment. Finally, let's go ahead and add the shift. The shift is also an attribute from the equipment element template. Let's also get the duration. Now the duration is a little bit different from the other attributes that we created. For the duration, I'm going to set the default EOM to be in minutes because I want to know the duration in minutes. For the value type, that will be a double. And for a data reference, I'm going to also specify PyPoint data reference. I'll click on settings. And here, I'm going to specify a reference attribute. Now, the duration is not actually an attribute that's found inside the elements, but we still need to provide a reference element attribute. So in this case, I'm just going to use the status attribute. For the by time, you need to specify not supported. And for the by time range, you need to specify a count. The combination of not supported and count will return the total number of seconds that this event frame lasted for. Now, you'll notice that in my default EOM, I specified minute. But that's okay because AF will automatically do the conversion from seconds to minutes for me. And finally, I want to know what the production rate was over the event frame. I'll go ahead and create a new event attribute template. And I'll call this average production rate. I'll go ahead and specify the data reference to be a PyPoint data reference and go to settings. I need to reference a particular attribute that I want to obtain the average for. And that attribute is the production rate. For the by time dropdown, I'm going to select automatic. And for the by time range, I'm going to select average. Now, if you've used summary statistics at the attribute level, you might be used to putting minus 1 hour, let's say, to obtain the average over the last hour. But event frames have a start and end time and a specific duration that we're not always sure about until they are generated. And with respect to that, the relative time doesn't really make sense, so we'll leave that blank. When we specify automatic, that basically allows AF to automatically determine what the average is based off of the duration of this event frame. Once we do that, I'm going to go ahead and check this in. And I always like to create a test event frame just to verify that our data here is correct. I'll go ahead and go to the event frame section. And I'll go ahead and create a new event frame. This event frame will use the event frame template of downtime or the downtime event frame type. Now, if I open up this event frame, you'll notice that this event frame can have a start time and end time. For now, I'm just going to use star minus 1h and star. Now you also notice there are a couple of other tabs here. You have a tab for child event frames, which will capture sub events that have occurred within the period of the parent event frame. But you also have reference elements. Reference elements allow you to link this event frame to the asset that generated this event. Let's go ahead and add a primary reference element. I'll go ahead and specify a single element. And let's say I'm interested in an event that was generated from BP988. Now if I go ahead and select the Attributes tab, we have the average production rate, the duration in which this event frame lasted for, the fault code, the status, and the shift. So it looks like here the status was in a downtime state. The shift was in the third shift. And the reason that we have a downtime is because of product flow stoppage. Now I'm going to go ahead and check this in. And now once I have configured the type of event frame that I want to capture for downtimes, I really need to go ahead and configure the automatic detection of event frames. So I'm going to go back down to my library, and I really want to generate event frames for any equipment that experiences a downtime. I'm going to go to the equipment element template. I'm going to select the analysis templates. I'm going to create a new analysis template to capture whenever the equipments go down. The analysis type here will be event frame generation. And I'm going to give this event frame generation name of downtime. Now you'll see here below that there's a drop down for event frame template, which just means tell me what type of event this is going to generate. And we want to generate a downtime event. Now downtimes only occur whenever the status changes from running to some other status that's not running. So for the start trigger, I'm going to specify a condition when the status attribute is not equal to running. I can also specify an end trigger here, but as long as I return back to the running state, I will go ahead and end this event frame. There are a couple other options here. There's an option for start trigger true for. If you have really noisy data that bounces around a lot, you might want to make sure that this condition is true for at least a couple of minutes. Otherwise, you're going to get a bunch of false positive event frames that last for a few seconds. There's also an option down below to generate child root cause event frames. This is pretty useful, especially for root cause analysis. You're oftentimes interested in what occurred before the actual downtime event has occurred. Let's go ahead and specify that we want to generate root cause event frame. I'll set the duration to be 30 minutes. And finally, we need to schedule this event frame detection. You could either schedule it to be event trigger or periodic. With respect to event frames though, it might not make sense to have it set to periodic for downtime events. You want to detect events right when they happen. One reason why you might want to use periodic is, for example, you want to create event frames for a particular shift or a particular day. But I'll leave that to you as an exercise. You also notice that for event triggered, we have an option of specifying what attributes we want to trigger this on. If we select the any input dropdown, you'll notice that we have status here. Going to go ahead and check this in. Alright, now I'm going to go ahead and go to my BP 988 asset. You'll notice that I have my downtime analysis, and this is linked to event frame generation. I'm going to go ahead and backfill this. I'll click on Start. And now if I hover over the status of this completed backfilling, you'll notice that we process 144 different events. If I go back to my Event Frames plugin and just click on the event frame search, do a refresh, you'll notice all the downtime events that have occurred for BP 988. If I expand out one of these event frames, you'll notice that there's a root cause event frame, which, if you look at a Gantt chart here, occurred 30 minutes prior to the start of the downtime event. If I click on the downtime event, you'll notice how we have our 5 event frame attributes. We have the average production rate, which looks like is at 9.5. The duration here lasted for 20 minutes. And the reason for this downtime is because of rejects. Okay, now that we have configured the automatic detection of our downtime events using asset-based analytics, let's go ahead and view these downtimes inside of Coresight. Now, one thing I want to point out is that with Coresight, you have related assets/events. Let's go ahead and just take a look at the events that we have. And notice a list of events that pertain to the downtime. What I can do is I can go ahead and just move my cursor over this clock symbol and click on it. What this will do is it'll automatically snap the time range of my trend to the time range of the downtime. I can easily go ahead and add more attributes to this trend to investigate this particular downtime. But I'm going to go ahead and just delete this trend. And what you can also do inside Coresight is you can drag a particular downtime event onto the display canvas. And what this will do is it'll just automatically just display or trend all the attributes that pertain to this particular downtime event frame. Now, what I'm really curious about is the fault code for this particular downtime event. So I'm going to go ahead and just display the fault code. And you'll notice that during this downtime event, which occurred starting at 8:30 in the morning until 8:50 in the morning, we had parts that were assembled incorrectly. Now, I'm usually interested in the time period that led up to this event. And with event frames, you could perform root cause analysis. You'll notice that for this particular downtime event, I could expand it out. And you'll notice that there's a child event frame called root cause. Now you can see that through the use of asset-based analytics to automatically detect these downtime events, we can use our client tools such as Coresight to quickly analyze downtime events that have occurred